Hello dear student, I am Vibhuti Prasanna Sakit, your physics faculty. I am going to teach you today electromagnetism. My dear student, see, in electromagnetism, if you see it very carefully, you will find it is made up of by two words, that is electro and magnetism. Electro deals with the electric field, whereas magnetism deals with the magnetic field. On further classification of electro, you will find it is classified into two groups. One is electrostatic, while another one is electrodynamics. So, what is electrostatics? We can define electrostatic as the study of charge at rest. Whereas, if we define the electrodynamics, it is the study of charge in motion. Study of charge in motion. See, in this line and in this line, you will find one thing very common, that is charge. Actually, this charge is very interesting thing, and it is the center of this whole chapter. So we have to understand what is charge. The question arises in our mind, what is charge exactly? What is charge? So if we define it, charge is the property associated with any matter. It is the property associated with any matter due to which it experiences or produces the electric field. What I say, just note it down. It is the property associated with the matter due to which it experiences or produces the electric field. Electric field. This is the definition of charge. So, after understanding this charge, we have to understand there are two types of charge. How many types of charge? There are two types of charge. First one is positive charge and second one is negative charge. First one is positive charge and negative charge. There are two types of charge, that is positive charge and negative charge. So my dear student, you must have to question yourself, what is positive charge and what is negative charge and how this charge can be created. Then you will find the answer is hidden in the atom. You have to understand the atom first, then only you can answer this, how positive charge and negative charge can be created. Let's understand this particular thing, how charge, that is positive charge or negative charge, is created. Let us see. We have to understand first atom. So if we see the atom, we find three things. First is electron. Second one, proton. And third one, neutron. Electron is negatively charged, whereas proton having positive charge and neutron no charge. Electron always revolves in the outer orbit of the atom. If we draw the simple diagram of the atom, we can make it like this. Let us consider this is the nucleus and this is the orbital of electrons. So this is the orbit of electrons, and this is under this nucleus you will find neutron plus proton. Here electron is represented by E, whereas proton is represented by P. Okay? So if you want to see this electron and proton having positive and negative charge, so you have to ask one question. What is the charge on electron and what is charge on proton? So electron and proton is represented as positive and negative E, with having the value of charge as 1.6 into 10 to the power minus 19 coulomb. This is the charge. The smallest charge is 1.6 into 10 to the minus 19 coulomb on the electron, or if we talk about the proton. This is the smallest charge. So if we want to talk about the smallest part of the charge, it is the smallest part of the charge. This is the smallest one. We cannot go further division of this. So another thing is SI unit of charge. It is coulomb and denoted by C. And CGS unit is state coulomb. State coulomb. So I think today you understand about the atom and the charge and how the atom having positive and negative charge, and what is the charge of electron and proton, the value of that charge. I think it is very much clear. We are going to understand the property of the charges. Here you will see the properties are listed in this particular board, and today we are going to understand the meaning of this. Okay, from the first it is written that like charge repel each other, whereas unlike charge attract each other. Let us see what is the meaning of like charge and repel each other. Like charge, it means, let us consider the positive charge. It means if the like charge will be kept, then it will repel each other, will go away from each other. Similarly, if we give negative charges, it will again go away. Okay? Now, see the third one. If we put the positive charge and one negative charge, what will happen? This is unlike charge. It means it will attract each other. Okay? So this is the meaning of this particular statement. Like charge repel each other and unlike charge attract each other. Now we are going to move on the second line, that is charges are additive in nature. What is the meaning of charges are additive in nature? We have to understand this by considering an object. Okay, so let us consider an object. Okay, so consider this is an object, metallic object with having positive 2 coulomb of charge at this particular point, negative 3 coulomb of charge at this particular point, At this particular point, you will find positive 5 coulomb of charge. At this particular point, it is positive, it is negative 2 coulomb of charge. So now, what is the net charge? What is the net charge? The net charge on this particular object is the algebraic sum of all the charges present on this particular material. Algebraic sum, it means this one, this one, this one, this one will be added. Let us see. Plus 2 coulomb, plus 5 coulomb, minus 3 coulomb, minus 2 coulomb. The net charge on this is plus 2 plus 5. It becomes plus 7 coulomb, whereas this becomes minus 5 coulomb. The net charge becomes plus 2 coulomb of charge on this particular object. So we understood this. Charges are additive in nature. Now we are going to see the next point, that is charges are conserved. What is the meaning of this particular line? Charges are conserved. Now to understand this particular line, we have to consider an isolated system. And if we talk about isolated system, it means nothing can leave that system and nothing can enter that system. Okay, that is the isolated system. Now let us consider the isolated system. Let us consider this is the isolated system with having 3 objects in it with name A, B and C. Let us consider on A it is having plus 5 coulomb of charge. On B it is having minus 2 coulomb of charge. And on C it is having plus 3 coulomb of charge. Okay. Now after some time, let us consider some operation is done over this. Okay. After some time, something happened. Let's see. After some time, what happened? The object A, B, C having minus 3 coulomb of charge plus 2 coulomb of charge. Find the value of x. So this is the answer. This is the question actually. You have to find the value of charge on this particular object C in the isolated system. So we have to understand it. Charges are conserved. In the isolated system, charge can neither escape nor enter. It means charge will be transferred from one object to another object within this certain limit, that is isolated system. Let us see. So it is 3 plus minus 3, 5 plus 3 minus 2. It becomes 8 minus 2. It is minus 8 plus 6 coulomb. And in this particular system, what we have? It is minus 3 coulomb plus 2 coulomb plus x. So you will find it. It is like minus 1 coulomb plus x equal to 6 coulomb. So we can find the value of x as 7 coulomb. So this is the particular value of charge on particular particle C in isolated system. It is very much clear to everyone. Now moving on to the next one, charges are quantized in nature. The meaning of these is very interesting. Charges are quantized in nature. Let us clean this board, then we are going to understand charges are quantized in nature and we will explain it. If charges are quantized in nature, it means and on any object it is charged. If it is charged, it means the charge on that object is the multiple of the smallest charge, that is electron. Yes or no? So this is given by Q and it is equal to plus minus NE. This is the formula of quantization where n is integer, and its value is 1, 2, 3, Nn. The value of n cannot be the fraction value, that is 1.5, that is 2.3, that is 4.6. It cannot be like this. Okay, so n will always be an integer and it is multiplied with the e. Okay, so this is the quantization of in nature. Charges are quantized in nature. Now, moving to the last property, that is invariability of the charges. Now we have to understand the invariability of charges. What is invariability of charges? If you see this word very closely, you will find invariability. It means charges will not vary. Invariability means charges will not vary with something. It means with something means with velocity. Charges will not vary with velocity. Okay, let us see. The value of charge will not vary with velocity. The meaning of invariability is this. But if we consider any object with having mass and if it is in some velocity, then it will change. Mass will change according to the velocity and it is given by a relation m is equal to m naught by 1 plus v by c whole square under root. So this is the particular equation of the variability of mass. Okay, so this is the thing, all the properties of the charges are explained here. So I hope you all have understood it very clearly, and I think there is no problem at all. Good luck. Thank you.